Hello everybody. In the last class we discussed demultiplexer and decoder. Okay. So we had seen that how demultiplexer can be also seen as a decoder by appropriate connection of the input, the data input and the strobe input. Now we extend the discussion from there where we started the understanding how decoder works to decoding for BCD input, and then we shall discuss encoder. So this is the concepts that we shall cover in this particular class. So BCD to decimal decoder. So what is BCD? BCD is binary coded decimal. So whenever we talk about decimal number 0 to say 9, so decimal means base 10. So 10 digits are there. So in terms of binary coding, so we represent them as 0000, that is your decimal number 0 to 1001. Okay. So that is decimal number 9. So this is the basic understanding that 0000 is decimal 0, 0001 is decimal 1, right? 1 up to it goes on 1001 is decimal 9, right? So when we talk about BCD to decimal decoder, so the input will be a BCD number, right, and the output will be whatever this BCD number represent. Okay, the corresponding output will be decoded. Okay, so if 0000 present is there, all zeros are present, so this will be active and rest all will be inactive. If 0001 is present, this 1 will be active, okay, and rest all will be inactive. So this is the understanding. This is what we mean by BCD to decimal decoder. So this is useful because in lot of cases these BCD numbers, this is what we shall encounter in different applications. Okay. So for that we have a standard IC, integrated circuit is available, chip is available, which is IC 7445. Okay. So what is driver etc. we shall see later. So first we look at the what is meant by what is done as decoding. So when DCBA is all low 0000. Okay. So what is happening here? So we see this is the one example we have taken. So this is low, right? So this is all these are low, right? So this is the inverter output. So these are all high. These are all high. So this high is going here, this high is going here, all these inputs of this NAND gate gets a high. So for the NAND gate, what will be the corresponding output? Okay, the output will be low at that time, right? So normal decoding operation we had seen that this bubble, this inverter will not be present. So here there is a inverter present, so output is made active low. Otherwise, if it is this inverter is not present, active high, at that time the output would have been high. Okay. And for rest of the combinations, one of the input would have been low, so output would have been low. Now since presence of this inverter at the output, okay, so all the outputs are made active low. So in this situation when all the inputs are low, okay, so this output is low and all other outputs are high. Okay, all our other outputs are high. This is understood. So this is when this is low, high, that means what is present here 0001, we shall again see the connection and we can see that these three are high and this is high and this again this becomes low, right. So sorry, this is low, high, so this is high, so this is your low and this has become high. So this high is connected here, right, and this is low, right. So all these four becomes high and here one of them becomes low. So this output is high and this is low and all rest of them are high. Okay. So this is what is shown here. So similarly it goes for every other cases. Now with these four inputs we can have possible 16 combinations, but since it is we know for sure that the input is a binary coded decimal, so only 0000 to 1001 is expected. So any other combination we are not bothered about, we do not care. Okay. So, for any other combinations, right, the output will be high. Actually, this is, we do not care about it. Okay. So, this is what we can see. Now, when you talk about this driver, as I said, this is meant for specific purposes. So, whenever these numbers are there and these corresponding number will, or LED will glow, or some number display will be there. So, we need to send little bit of more current than normal logic circuit operations. Okay. So, the output here is through open collector, which can sink much larger current than the normal TTL. Okay. So, this is useful for as I said, displays and other things, where this binary coded decimal and corresponding display is connected in tandem. Okay. So, this is the meaning of decoder driver. So, the output stage of it will be open collector. Okay. So, we can see one example. The example is, so this is a decoder driver, right. So, here we are putting a what is it called, LEDs are connected. So, if the LED drop here, we consider as 1.6 volt, right. This resistance, current limiting resistance is 330 ohm, and the open collector output, we know the open collector output, how does it work, right. So, this is the output stage. So, here it remains open, basically you are connecting it through a resistance. This is the resistance we are talking about, to 5 volt supply, right. So, this is in saturation. So, if we consider the saturation voltage is 0.1 volt, okay. So, then LED current here is 10 milliampere. Okay. So, this is the way we can calculate. So, for any other value of the resistance, another current will be, so LED will be brighter or little less bright, clear. We can do simple calculation around it. Now, another important application of this is BCD to 7 segment decoder driver. Okay. So, what do we mean by that? So, often these BCD numbers are displayed. So, 0 to 9 is to be displayed in a 7 segment display. So, 7 segment display, how does it look like? So, if you have seen any, so basically there will be 7 such segments, A, B, C, D, E, F, G. Okay. And when 0, 0, 0, 0 is presented here, 0, 0, 0, 0 is presented here, right. So, these are all LEDs, these are all individual LEDs. So, this is the corresponding LEDs A, B, C, D, E, F, G that you see over here, okay. But they are arranged in a package where it would look something like this. So, there are these pins are there, these pins are there, right, and this is the package where these LEDs are present. So, 7 LEDs are there. Okay. So, this whenever 0, 0, 0, 0 is presented, so which LEDs will glow? So, this LED, this LED, this LED, this LED, this LED and this LED, the corresponding LED, these are the LEDs that will go. That means A, B, C, D, E, F, G will not glow, right. So, when 1 is present, that means 0, 0, 0, 1 is present, which LED will glow? B and C, B and C will glow. So, similarly for the rest of the cases, Now, you can understand that A will glow for the cases when at the input 0, 2, 3, 5, 6, 7 these are present, right, and B will glow when these are present. So, what you can do? You can generate all the these possible cases and then these min terms, and you can just simply sum them up. This is one way of generating the circuit. So, basically this is what is you are looking for when you are generating a BCD to 7 segment decoder. And since we are trying to light up LED which will glow and will so we are also considering a driver. So, this driver is again a open collector kind of output. Okay. And we are saying that this is a common anode type, where because BCC is connected to this diode, the positive side of it, okay. The anode, it is in earlier context it is called anode, okay. And if we had connected the common, so basically the output was going to each of these inputs, and the ground part is, this is connected to the ground, that is common, that would have been a common cathode type, okay. and this IC 7446, this particular IC, which is the decoder driver, other than the basic concept that we have discussed here, it has got additional functionality like blanking of leading zero, lamp test and other things. Okay. So, that we are not discussing, that you can think about when you try to get an application around it. So, having discussed a decoder, we would like to take up encoder also, encoding operation, how and what would be the circuit for a encoder. So, what does the encoder do? It is just opposite to decoder. An encoder converts an active input signal to a coded output signal, So, here is an example. So, in this case, this is a decimal-to-BCD encoder. So, the possible are 0 to 9. Okay. So, these are the inputs that are present and the corresponding outputs are 0000 to 1001. So, the encoded one. So, one simple arrangement that you can see, whenever 0 is to be sent, coded. So, you just connect this one and you can see that this has got connection with none of these OR gate outputs. So, the OR gate outputs will be 0000 in such a situation. So, idea here is there is no enable input to begin with or in a strobe kind of thing, which we shall see later. So, that one of the input is always present, one of the input, decimal input is always present, right. So, if one is pressed, right. So, then what will happen? Only this one is getting output. So, DCBA, so 0001 will be the output. If 2 is pressed, only you can see that 2 is connected here to this one. So, only B will be getting the 5 volt 1 here and rest all are 0. So, it will be 0010. When 3 is pressed, what will happen? You see that this is getting connection and this is getting connection, right. So, B and A, so 0011. So, that way it will go on and we can have a encoded version of this. So, instead of 10 signals sent, we can send only 4 such signal in the encoded form, which will carry the information of this 4, right. So, this is the idea, right. So, with m outputs we can send up to 2 to the power m number of input in a encoded form. Okay. Now, in this particular example, what you can see that when both, as I said, here there is a condition, a constant that one of the input is always present, always pressed. Now, if more than one input is pressed, what will happen? For example, we take the example say 1 and 2. If 1 and 2 are simultaneously pressed, simultaneously present, 1 and 2 both are simultaneously present, what will happen? So, this will become high and this will also become high. So, the output will become 00311. So, it will appear that to the external world that input 3 is present instead, which is erroneous. Okay. So, in this case we need to think of a different kind of mechanism to achieve encoding, and then there comes the concept of priority encoding. Okay. So, what is that? So, here we take an example. So, in this example we take 4 inputs, only 4 inputs which we can extend later. So, D3, D2, D1 and D0, and in these we assign highest priority to D3, then to D2, then D1 and then D0. D0 has the lowest priority. So, and these are the 4 inputs. So, the encoded we need 2 outputs which will encode these 4 inputs, right. So, we are naming them C1 and C0. So, because D3 has got highest priority, when D3 is 1, D3 is active, irrespective of other inputs, the outputs are according to D3, which is 1 1. We are that is the way we are designating it, D3 1 1. When D3 is 0, okay, if D2 is 1, irrespective of the other input, if D1 is present, D0 is present, we do not care about it. So, the output will represent D2 only, and we designate D2 as 10, we encode D2 as 10. Similarly, if D3 and D2 are 0, then D1 will be seen in the output irrespective of D0 is simultaneously pressed or not pressed, okay, and finally D0. So, that is 0 0. Okay. So, this is what we see as the truth table. Okay. Now, so if you look at this, the C1, how we can get the realization of the C1. One way, of course, is just looking at the combination and all, and figuring out that C1 is D3 plus D2. You can see the D3 and plus D2, right. The other one is C0 is D3, and it is not plus D1 when it is present, because if D2 is present, D2 has got higher priority, at that time this should be 0. So, if D2 is not present, right, then if D1 is present, it will be high. Okay. So, this is what we can see, I mean just by looking at the truth table. Otherwise, we have got our conventional way of working out through Karnaugh map. So, D3, D2, D1, D0, if we put it into the Karnaugh map, okay, this is what we shall see, and this is one term we are getting here, another term over here. And similarly, for C0, if we just put it into the map, this is what we shall see. This is 1 D3, and this 1 1, okay, and this 1 1 can be grouped together. So, this is giving you D2 prime D1. So, this is the way also you can get it. Okay. So, when you realize it, you will get a priority encoding. That means, when both 1 and 2 are pressed, okay, so it will not be giving you 3, the earlier case that we had seen. So, it will give you only 2, right, 1 0 as the encoded output. Clear? And one more thing, that this is made cross because 0 0 0 0 case will never appear. Okay, that is the understanding. Now, let us look at one practical circuit where this priority encoding is happening. So, this is decimal to BCD priority encoding. Okay. So, in this case, the higher number has got higher priority, similar to what we had discussed during the development of the concept for priority encoding. And we look at the example where 1 and 2 pressed simultaneously. Let us see what happens. So, when 1 and 2 pressed simultaneously, we shall see that this 2 over here, right. So, if this is your all these things are your this is your active low, right. So, if this is your low and this is your low, this is high and this is high and this is your low. Is it okay? So, this low will go over here, and even if this is present, so this will make this output low. Is it clear? And whereas this high will continue, and this will make this output high because of the presence of the other combinations. So, this is what actually is making, even if both are simultaneously present, pressed, this one inactive. Okay? And the corresponding output will be there. So, what is happening here, looking at the other aspect of it, when 9 is low, right, the DCBA, this output will be low, high, high, low. So, you can just look at follow the circuit and you can see it. Okay. Is it clear? So, when 1 is present, so it will be low, high, 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 low, right, sorry. Yes, this is when 1 is present, this is the case, that is what we will see, right. 2 is present, you will see high, high, low, high, right. But when 1 and 2 simultaneously is pressed, you will see H, H, L, L, when 1 plus 2, that is the priority encoding, sorry, H, H, L, H, okay, that is included in this particular circuit. So, similar thing for 8 to 3 priority encoder. Okay. So, this is 74148, again this is an IC where you can see the same concept, but we have taken up this one to make you understand the how cascading etc. is done in case of encoding operation as well. So, here other than the basic circuit, you have got two one input here, enable input, and two outputs are there. This is group select data, and this is enable output, right. So, what you can see, then when this enable input is high, okay, at that time this GS is high and enable output is also high, right. And when EI enable input is low and none of the input is present, 0 to 7 is present, 0 to 7 is 8 to 3. So, 0 to 7 are the corresponding inputs. So, none of them are present means active low. So, low, it is low, then all the outputs are high. At that time GS is high and enable output is low. So, basically this low is making this low. And finally, when enable input is low and one of the input is low, one of the input is active, right. So, at that time the corresponding output will be there. If it is 7, then it is LLL, that is 0 0 0 because it is active low, that is another part of it, the encoding part of it. And what you see at that time, if data is present, GS will become low. Okay. So, that a group data in this particular group it is present, that is what it is saying, and enable output will go high. Okay. So, this is the two control inputs, two control outputs, and one control input is associated with this circuit. Okay. And rest of the thing are similar, rest of the thing as we had seen before. So, if 7 is low, output is LLL, low 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 0 0 0. If 6 is low, right, 6 is low, then the output will be low low high, okay, because it is active low. So, this is considered as active. Okay. So, this is the way it will go on, and here also the higher the number, the higher is the priority, and input output we have seen to be active low. And finally, we see that how this can be used for enhancing the size of the encoder. So, this is higher order from lower order for IC 74Y8. So, this EI and EO, enable input and enable output, are useful for cascading. So, this is what we have seen, this is the corresponding connection. So, these are essentially AND gate. Okay. These bubbles are present and then there is a bubble over here. So, this is making a essentially an AND gate. So, basically it is realized by IC 7408. So, IC 7408 we have seen before, it is a quad 2 input AND gate. Okay. So, so each one is having a 8 to 3. So, this is also 8 to 3. So, put together this is 16 to 1. So, this EO is connected to EI over here. Okay. This GS group signal output, we have seen the truth table before, the description of the truth table before. So, this GS and the GS, these are coming together, right, and this is mentioning that the priority flag, that it is the priority is being provided here, and the outputs now, because it is 16. So, encoding will be done by 4 outputs. So, these are the 4 outputs, okay, and these are the AND gates, these 3 AND gates, and this is coming directly from GS. So, if you just look at the corresponding truth table and their description, you will see if you place the data and check the output, you will find that if say 0 is present here. So, it will be low, 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 it is activated. If 1 is activated, it will be low, low, then the way this is the way we have seen. So, basically when we see 0 being activated and when you see 1 being activated, we shall see that 0 is high all H because it is active low, and when 1 H. So this is the way it will go on, right? And only when this is up to 7 here, so here it will go up to 15, so it will become LL, right? So this part look at it carefully how it is done, because it is active low and this is active low, which you need to be a bit careful. So what is active high and what is active low, how the output descriptions pan out. Okay. So when 7 is present low, so this is LLL, this is the thing that you have to remember. Okay. We might get confused, so we should be careful that we do not get confused about it. Okay. Now to conclude, Decoder-driver is capable of providing higher current through open collector output, as for example BCD-to-Decimal and BCD-to-7 segment Decoder-driver. Okay. And this is useful for display devices. Okay. Often these BCD numbers are displayed. And encoder converts an active input signal to a coded output signal. And priority encoder is useful when more than one input is active. The output is according to the priority assigned to the input. So we had seen the examples where higher number was given a higher priority, but you can change the priority as per your requirement, and accordingly the design will be done. And certain priority encoders can be cascaded to encode larger number of inputs. So we saw the example of IC 74148, which has got group select output and enable input and enable output, which can be put judiciously, and from 8 to 2 such 8 to 3 encoder 74148, we can get a 16 to 4 encoder made. Okay. Thank you.